Okay, so we're going to pick back up here at the bottom of page 4. So we're going to draw a particle model of molarity of solutions. We're going to assume that 6 particles equal 1 mole. So if I want to have a 1 molar solution, like we said in the previous one, 6 particles equals 1 mole, and let's assume that this is 1 liter. So I'm going to say my circle is 1 liter, my circle is 1 liter, and my circle is 1 liter. So I need to get 1 mole here. So how would I get 1 mole? I need to have 6 particles. So let's make my solute, make it blue just for fun. We need to have 6 of them. So 1, 2, 3, 4, 5, and 6. So how many particles do I need in my 2 molar solution? Well, I need twice as many moles. And from my previous part, I would know that that would be double, so that's going to be 12. So I need to have 12 moles of solute. And now if it's only a 0.5, I need to have 3. So let's see. So I don't need 6. I only, oh, that didn't work. Just trying to be fancy. Let's see if I can say I want you to draw 3 moles here. So 1, 2, 3. So that's a visualization of what's going on at a particular level. So which of these solutions is more concentrated? Well, look at which one has more moles of solute in the solvent. That's going to be the 2 molar. And for your explanation, explain that picture. There are more moles per that 1 liter. Which one's the most dilute? That's going to be the 0.5 molar. There are less moles of solvent per liter of solute. Here's a thing you must remember from the beginning of the year. 1 liter is exactly 1,000 milliliters. That's a conversion factor you need to have memorized. Okay, let's flip the page. So now here are some example problems. Now these are all going to have a very similar setup. So all of these I'm being asked at the beginning for molarity, and then I'm being asked to solve for moles. So let's start with my general equation. Molarity equals moles per liter. I'm actually going to put that up top. That's my general equation. That equation can be rewritten as M equals N over L. So this is the equation that I'm going to be using to solve every single problem. Okay, good. Oops, I got a stray mark on some of these. So let's look at problem number 1. What is the molarity when 0.5 moles are dissolved in 2 liters of solution? So 0.5 moles, that is my N. 2 liters, that's my liters. So this is going to be 0.5 divided by 2. So take a second, either do that mental math in your head or pull out your calculator. So 0.5 divided by 2, that should be 0.25, and my label will be molar, capital M. And if we wanted to round to sig figs, we would have to say 0.3 because they only have 1 sig fig there. Number 2, what is the molarity when 1 mole of solute is dissolved in 0.5 liters? So 1 mole per only half a liter. So 1 divided by a half, do your mental math or pull out your calculator, that will actually give you a 2 molar. This one is going to be a lot more concentrated. And number 3, how many moles of HCl are in 300 mils of a 12 molar solution? This one needs a little bit of extra care. So milliliters to liters, you can move your decimal 3 places. This is 0.3 liters. So this time I know that my molarity is 12.0, and I'm trying to solve for N over my 0.3 liters. So how do I isolate for N? I'm going to multiply each side by 0.3. So I'm taking 12 times 0.3, and I'm going to get 3.6 moles. Now, how many sig figs should I have? There should actually be 3 sig figs. I'll make that 3.60 moles. Number 4, how many moles of sodium sulfate are present in 25 milliliters of a 0.12 molar solution? So we've got to convert that milliliters to liters to move your decimal 3 places. We're dividing by 1,000 to 0.025 liters. and it's 0.12 molar. So I'm saying that 0.12 molar is equal to N, my number of moles, over 0.025 liters. So we're isolating and solving for N. So you're taking 0.12 times 0.025, and you should get 0.003. Now, how many sig figs do I want? Gotta have at least 2. Make that 30, and that's gonna be moles of my solute, which is sodium sulfate. Remember your formula and your naming rules here. This is good practice back from chapters 6, 7, and 8. Okay, so here's your general diagram that you're following. We always want to use moles as an intermediary. If we're going from molarity to moles, we have to look at our conversion factors. For this part, it's really helpful if you let the units be your guide. So if I have molarity and I want to get to moles, I'm going to be multiplying by liters, like I did in the previous problem. And if I have moles and I'm trying to get to molarity, I'm going to be dividing. Okay, now remember, if I have moles and I want to get to grams, so let's say I have moles and I'm trying to get to grams, I've got to have moles on the bottom and grams on top of my factor labeling problem. So what am I doing with the molar mass to get from moles to grams? I am multiplying by the molar mass. Now let's say I have grams and I want to get to moles. What am I doing? I'm dividing by the molar mass. So if this is helpful, here is kind of your bridge going through the mole, or just do your factor labeling problems or your algebra. That will get you set up correctly. Okay, so let's go through some of these other practice problems. We want to have the same setup. We're going to use that same equation. So M equals N over L. And that's going to help us get started. So we have 0.2 moles of sodium carbonate used in the last, 0.2 molar sodium carbonate used in the last lab. How many moles were in 1 liter? Okay, so I know that molarity is 0.2, and that's going to be equal to how many moles over 1 liter. So what is N equal to? I've got to isolate and solve for N, multiply each side by 1. That means it's 0.2 moles. For B, how many grams of sodium carbonate were in 1 liter? So if I have 0.2 moles, let's say blast from the past, 3373 factor labeling, I want to get from 1 mole the grams. How do I find my grams? Shout it out. You're right, periodic table. So what is the molar mass of sodium carbonate? You're taking sodium plus carbon plus oxygen, and you should get 105.99 grams per mole. So we're taking 0.2 times 105.99. You should get 21.198. That is too many sig figs. This actually is only accurate to about 1 sig fig. Yikes. So if we had to round that, this is going to be about 20 grams. Okay, let's look at problem number 2. If 50 grams of silver nitrate were dissolved in 1 liter, what's the molarity? So first I've got to solve for moles. So if I've got 50.0 grams of silver nitrate, and I want to get from grams to 1 mole, I must go to the periodic table. Molar mass of silver nitrate is 169.88 grams per mole. So I'm going to take 50 divided by 169.88, and that gives me 0.294325 moles. Now I'm not worrying about sig figs yet. I want to keep as much info as I can to help solve this problem. Okay. So then when I'm solving for molarity, molarity is number of moles per liter. So I'm going to be taking the 0.294325 moles and put that over how many liters that I have. They're telling us 1 liter. So divide that number by 1. And I only want 3 sig figs though. So what is my final answer going to be? It's going to be 0.294 molar. And we could also say what it was silver nitrate. Good. So make sure if you are struggling with that math, pause the video, work through those problems by yourself, and check your work. Okay, let's flip to page 6 now. We're going to solve for what volume of water must be used to dissolve 100 grams of C6H12O6 to make a 1.5 molar solution. Okay, so you should recall that this is glucose, and we need to convert to moles. So if I have 100.0 grams of glucose, I need to get rid of grams and go to moles. Use your periodic table, pause, and find the molar mass of glucose. You should find that is exactly 180.18 grams. So how many moles of glucose do I have? I've got 0.55500 moles of glucose. Now I want to solve for my volume. They are telling me I want a 1.5 molar solution. So 1.5 molar is going to be equal to my number of grams, 0.55500 moles, over liters. This is just an algebra problem. So if I'm going to isolate and solve for liters, you could go about it whatever way you want. You could multiply liters to each side and then divide each side by 1.5. So however you like doing your order of operations, that is fine by me. You should get a final answer, though, of 0.294. And that is rounded to, let's see, how many sig figs do I want? Here's my limiting factor. So this would be a 0.29 liters. Did I answer the question? Yes. What if they asked me for milliliters? We would just multiply by 1,000 or move 3 decimal places, and that would be 290 milliliters. So you could see a question like that on the test. The question, what do you always find first? Well, we need to know moles and we need to know liters. So if you've given grams, you got to find moles. If you were given milliliters, you got to go to liters. So we always need to find moles and we always need to find liters. It just depends on what you're asked to be solving for there. Okay, I would say you probably have learned enough to try the next 2 problems, so this would be a good point to pause your video and then come back and check how you did on numbers 4 and 5. So pause your video, work through these, show all your work, and then come back and check your solution. Okay, now let's check your work. So for number 4, you should have got that you need, or you're creating an 8.6 molar solution. Converting grams of sodium, you divide by the molar mass, you get 2.145 moles. 250 milliliters, divide by 1,000, you get 0.25. So take those numbers, divide them, and report it to 2 sig figs from right here. Number 5, let's see. So you need to get 500 mils to liters, divide by 1,000. We're told 6 molar. I am isolating and solving for n, my number of moles. N is 3 when you do your algebra, so I have 3 moles. That does not answer my question yet, though, because they want to know grams. So if I know moles, I need to multiply by the molar mass of calcium chloride. Your formula is CaCl2. Your formula was NaOH. And that would give you 332.94 grams, which would be just about 300 grams. Okay, the next video, we're going to finish up with the end of page 6 and all of page 7.